Hey everybody, Mr. Lavasser with you again on an assignment. Our assignment is writing the Peel paragraph. Our topics will be the cross-cutting concepts, two cross-cutting concepts, one the concept of scale, and two the concept of the relationship between form and function. The concepts that we'll be discussing in this science course are based on the next generation science standards. They're cross-cutting concepts. They go from subject to subject. So my friends, let's have a look at cross-cutting concepts. Here's a paragraph about them. Concepts are big overarching ideas that connect topics to subjects. Cross-cutting concepts are concepts that bridge disciplinary core boundaries, having explanatory value throughout much of science and engineering. These concepts help provide students with an organizational framework for connecting knowledge from the various disciplines into a coherent and scientifically based worldview. Examples include patterns, cause and effect, scale, proportion, and quantity, systems and system models, energy and matter, structure and function, and stability and change. Concepts are often communicated with nominalizations of words that represent abstract ideas. Friends, I took that paragraph from the Next Generation Science Standards, and I want you to notice that it was written in the Peel pattern. And whenever you look at a science textbook, the explanations will often be written in this same exact Peel pattern. 4 sentences. Sentence number 1 presents the idea. Sentence number 2 explains the idea. Sentence number 3 gives an example of the idea. And sentence number 4 connects the example and the explanation. So, science is based on the concept of scale. The Greek philosopher Aristotle, the father of Western science, his teachings emphasize dividing, categorizing, and organizing the world. And there's a picture of Aristotle. The technical definition of science. Science is the systematic and rational study of nature. Systematic, the scientists use experiments and the scientific method. Rational, the root word of rational is ratio. Ratio means a comparison of things by dividing. So the concept of scale is what makes science rational. The concept of scale allows scientists to divide nature into smaller and smaller sections, which allow scientists to concentrate on one part of nature at a time and then compare and organize those parts. Think about these words for a minute. Rational, ratio, scale, divide, fractions, proportions. These are all the same basic idea, dividing things up by organizing them and comparing them. Divide things to better understand them. Compare the different sizes. This is the concept of scale. Analysis. Analysis is the process or the action of dividing things up to better understand them. This is the concept of scale. So, from the giant galaxies down to the subatomic particles, we divide nature up. Another example, if we have quarks, they can be organized into protons and neutrons. Protons and neutrons make up the nucleus of an atom. The positive protons attract the negative electrons. The atoms join together to make matter. The job of science is to explain nature. Scientists make sense of nature by breaking it into smaller and smaller pieces and organizing those pieces into an orderly system that shows distinct patterns throughout nature. This is known as the concept of scale. Look at that picture again. Matter divided into atoms, atoms divided up into the nucleus and the energy levels, the nucleus divided into protons and neutrons divided into quarks. For instance, the concept of scale divides entities such as matter, you just saw that, or the biosphere. Divided entities and the ideas can be classified and arranged by similarities. Here we have a picture starting on the right. We have the biosphere. The biosphere can be divided into the different ecosystems. The ecosystems can be divided into the living communities. The communities can be broken into the individual populations. A population, you can break that up into just one organism. That organism can be divided into its organ systems. The organ systems can be divided into the organs. The organs are made of tissues. Tissues are made of cells. Cells are made of macromolecules. Macromolecules are made of monomers or subunits. And subunits or small molecules are made of atoms. Concept of scale. So, for instance, the concept of scale divides entities such as matter. The biosphere divides entities and the ideas can be classified and arranged by similarity. The concept of scale in science divides nature and compares the parts to make clear the relative sizes of the different entities or topics that make up nature. And let's look at that paragraph. That paragraph follows the Peel pattern. We have a present sentence. We have an explain sentence. We have an example sentence. And we have a linking sentence. Analysis is an example of the concept of scale, and the drawing you see is the graphic organizer that people use when they're analyzing. The large gray box can be divided up into the four small boxes. Analysis is an important action or process in school, and particularly in science class. An analysis is a careful and detailed study carried out to determine the elemental or underlying constituents and structures of some entity. In school, these entities may include an analysis of nonfiction or informational or scientific texts. Similarly, a scientific analysis may be done for a natural phenomena, which is another example of the concept of scale. The concept of scale is used to analyze scientific data or academic writing. In the analysis, we divide and organize information about nature. Graphic organizers shows analysis, one entity or participant divided into its component parts. Here we have science, natural science, divided into biology, physics, and earth science, or the physical sciences. Biology can be broken up into zoology, botany, ecology. Physical sciences can be broken up into physics and chemistry. Earth science can be broken up into geology, meteorology. So we take something, we divide it into smaller and smaller pieces. So we can also analyze that text. Look at that text. We find the zigzag or the subject-predicate connection, and we also see the ziggity or the subject-to-subject pattern. This is how science, in science writing, this is how connections are made. This is why science writing is dense. We can also analyze this paragraph for the Peel structure. One paragraph divided into four separate parts, each with its own job. Let's look at one of the key concepts. Form determines function. Something shaped gives it what it can do. Form determines function means that an entity's shape causes the characteristics and properties of that entity. For example, jacket and a backpack. These have about the same amount of cloth in them. They might even have the exact same kind of cloth. But because the backpack is stitched differently than the jacket is stitched, they have different jobs that they can do. The form that they were stitched into determines the function or the job that they can do. Each element on the periodic table has unique chemical and physical properties. Those properties are caused by the element's atomic structure. The reason why gold acts like gold is because of the electron configuration of the electrons in a gold atom. Carbon acts like carbon and is the element of life because of its electron configuration, because of its form. Therefore, it has a function. Similarly, molecules have distinct shapes. You throw water up against a piece of glass. You take a shower, you need to towel off. You throw water against a piece of glass, little droplets will stick. Why? Because the shape of the water molecule gives it particular properties. And those properties are adhesion, it sticks to things, and it's cohesive, it sticks to itself. The idea that form relates to function is more than just in things like water or the atoms of gold or backpacks and jackets. The idea that there is an important relationship between form and function can apply to both our study of science content as well as science literacy. There are different forms or genres of organizing a text, and each has a specific function or purpose. For example, we have the peel pattern, present, explain, example, link. And that is for explanations. The pattern, make a claim, show supporting evidence, and your reasoning, claim, evidence, reading, is used for arguments. And for narratives, there's a pattern, and that is the orientation, the complication, and the resolution. So text structure and text function are related. Notice that this is in the Peel paragraph form. Have a look at your assignment. You're asked to write an explanation based on the prompt, explain the concept of scale. There's a picture that might help you. So you're going to write at least 4 sentences. Use the prompt to write a present sentence. So take part of the prompt, write your presentation sentence. Write an explanation sentence. Consider using is or are as the verb. You want to make this is something, is or are, so that there's a relationship there. Your example. Provide an example of the concept of scale. The sentence you might want to start with for example or with for instance. Your 4th sentence, you want to link the explanation and the example together. The second prompt for this assignment, explain how the form of a carbon atom allows carbon to be the element of life. And there's an image that might help you. And what are we going to do? Use the prompt to write a present sentence, write an explanation sentence, consider using is, are, or has or have. Has, have, if you want to describe the atom, use has, have. You're going to be stating some of its characteristics. Is, are, this equals that, or this has that. Those are excellent ways to make an explanation. Sentence 3, provide an example of why the structure of a carbon atom allows carbon to be the element of life. Consider starting this sentence with for example or for instance. Link them all together. Now when you've written those 2 paragraphs on side 1, you'll exchange your paper with someone and they will read your paper and they will edit and give you advice for revising. You can have a classmate or a teacher or your folks or your brothers and sisters proofread your paper for you. This step changes informal writing into formal academic writing. When someone looks over your paper or when you're looking over somebody else's paper, here's the things you want to do. 1, you want to point out any errors in the science. If they've explained the concept of scale when they were asked to explain form determines function, you need to help them out with that. Any of the science content that's wrong or that you think might be a misconception, help the person recognize that. Look for any misspellings, grammar issues, punctuation, those types of things. Help them find those. Number 3, check that there are at least 4 sentences. If there aren't 4 sentences, you probably don't have a Peel pattern. Look and make sure that they have repeated subjects or predicate to subject, ziggity zigzag type connections in their paragraph. 4, make suggestions about possible changes to wording that might improve the reader's understanding. And 5, help them create elaborations. particularly for the example and the explanation. Starting with that explanation, you might need more information than the first sentence that they've given you. So you might need to add a second sentence or another clause attached to the first sentence, which will give the explanation greater meaning. Same with the example. Maybe you want to follow the example up with a second example or go into detail on the second example. So my friends, thank you for your hard work. Thank you for all that you do to make sure that you're learning the content for this science class, and I'll see you in class. If you need a copy of the assignment and you can't get on Schoolology, shoot me an email. It's at the first slide.